Hello everyone, this is part 2 of my building a Nixie tube clock project, and in this part I'm going to be showing off how the Raspberry Pi is going to be able to communicate with the Nixie tubes to be able to show the time. But before I get to that, you might notice that the breadboard layout is a little bit different. And that's because it is. I spent a couple hours a couple days ago completely redoing this for a couple reasons. One, just because my original layout was kind of messy, and this is a lot cleaner, a lot easier to read. But secondly, because of safety reasons. So the other day I was testing out all of the Nixie tubes and all of the driver chips to make sure all of them worked. And they do, which is great, but halfway through that testing, something on the board was shorting out and nothing was working, and I could not find where the short was. And so the only way I was able to solve it is just by completely redoing everything, which, like I said, I needed to do anyway, but this is just a much better design from like a electronic safety standpoint, because I've got everything separated out between 3.3 volt stuff, 5 volt stuff, and 170 volt stuff. And the 170 volt stuff, I'm not even using the voltage rails for this. Everything is just as close to each other as possible, and everything that shouldn't be touching is as far away from each other as possible. Not to mention, it's on a completely different breadboard as the other stuff, just so that they have no chance of interfering with each other. And so that's just a much better way to do it, and I'm much happier with this. So, needless to say, I'm kind of terrified to use this now. I really hope another short doesn't develop. That being said, I am going to turn it on for you today, just to show off the stuff that I did. So, I'm going to turn this on, and then after the demo is done, I'm going to kind of explain how it worked. So, as you can see, the Nixie tube is lighting up, and so this isn't like plugged into any computer, by the way. This is all from the program running stored on the Raspberry Pi Pico on boot up. So as you can see, it flips through all the numbers, which I showed last time, but there is something I forgot to show last time, and it is the decimal points. So you just saw that. There was like on the left side and the right side, there was a little dot inside the tube. I'm going to wait for it to come back again so that you can see it again. It's left and right decimal places. And the purpose of that, I'm pretty sure this was originally meant to be used in like, I don't know, like a calculator or a numerical display or something. And so, you know, the purpose of that would have been like, if you want like 3 point something something, like you would use the decimal point inside the tube to show that. What I'm going to use it for, I don't really know yet. Obviously there's no decimal points in the time, so I don't really need that. But I'm thinking maybe, like, since I'll have 6 tubes in a row and all of them will have decimal points, maybe I can turn it into a cool effect, like when the Raspberry Pi is accessing the internet for the weather, it'll like all the decimal points will kind of like light up and go back and forth, like I don't know, like Kit from Knight Rider, or the guys from Battlestar Galactica. I think that'd be cool. But we'll see how that works. So yeah, something else I forgot to mention in the last video were these. These are also Nixie tubes. They're little tiny ones. They don't display numbers like these ones do, but these just have a single light in them, so it's just like, it's a dot, and the dot is either on or off. And I'm pretty sure these were also meant to be used as decimal points. I'm not really sure why, since there's already decimal points in there. But anyway, I'm going to use these probably to show which function the clock is currently displaying. So I think I'll have all 4 of these in a row, and then this one will be like, you know, like when this one's lit up, it'll be showing hours, minutes, seconds. When this one's lit up, it'll be showing day, month, year. When this one's lighting up, it'll show the weather, stuff like that. And so, you know, I wanted to have these running for this video, but I tried using these with one of these driver chips, since these driver chips are meant to be used with Nixie tubes, but for some reason I couldn't get those to work. Instead of like the tubes being on or off, it was like on and slightly less on. I don't really know why, but for these I ordered some like high voltage transistors, and I think that'll work much better than these, but I'll have that running next time probably. So I'll save that for a future video, but I just wanted to mention those. Oh, and in addition to having 4 of these for each function, I'm going to have 4 buttons for each function. Not these buttons though, probably. These buttons are kind of flimsy and boring, and they came with the this dinky breadboard kit that I bought like 5 years ago when I was in college. But anyway, I'm thinking like in order to kind of stick with the aesthetic, it'll be like 4 kind of like retro styled buttons. Or maybe like switches or knobs or something. I just want something that, like, you know, like the Nixie tubes and stuff, looks like it could have existed in the 1970s. And then of course there will be 4 buttons, and each of those 4 buttons will correspond to one of these, and so that'll like switch it to displaying that function. So if you want to see the weather, then you push the weather button, and then the light will light up, and you know, I think you get the idea. That being said though, I have no idea what kind of like retro buttons I'm going to use. I kind of did some light research but couldn't really find anything I liked. So if you know of any like cool retro buttons that you think I should use on the clock, definitely like leave that in the comments down below. I would really appreciate your help on that, helping me find those for the clock. Yeah, so now, as promised, I'm going to finally get into how this tube is connected to the Raspberry Pi. So, just like last time, inside of here, there is this driver chip, which is connected to all the numbers, and that is converted into binary. So there's 4 lines, and each one of those is 4 bits, and 4 bits are needed to show up to 10 numbers. So you can see these 4 wires are going from the chip to this chip over here, and it is in fact not going directly to the Pi, it's going to this thing, and what this thing is a GPIO expander. So the thing is, I have this for 2 reasons. One, the Raspberry Pi, so the Raspberry Pi only has a certain number of pins, right? I need 4 pins for 4 bits to be able to connect with this, but since there's going to be 6 tubes, in addition to an additional driver to drive the decimal points, and in addition to each of these 4 lights, and in addition to 4 buttons, that's like 36 GPIO pins. This does not have 36 GPIO pins. This has like, I don't know, like 20 something, so it's nowhere near enough, right? So what these chips do is they communicate to the Raspberry Pi via an I2C connection, which is just these 2 wires here, and those can give you each one of these chips. There's actually 2 chips here, they're like right next to each other, but each one of these chips has 16 GPIO pins on there, and you can have as much as 8 of these on the same 2 wires. So you can essentially turn 2 wires into like as many GPIO pins as you could possibly need. And so like I mentioned, I'm doing this for 2 reasons. One, because the Raspberry Pi has nowhere near enough GPIO pins that I need. But secondly, because I think in the final design, I'm going to have these separated into 2 halves. Like there's going to be 2 circuit boards. One is going to be on top and it's going to have all the tubes and stuff on it. And one is going to be on the bottom and it's going to have the Raspberry Pi and a couple like power things, that kind of stuff, just to like save some space. But, you know, if the Raspberry Pi is going to be on the bottom half, in order to communicate with the tubes on the top half, like I said, you know, it's 4 wires per tube, so that's like 36 wires that need to go from the bottom half to the top half. Except if I put these on the top half instead, it's only 2 wires that need to communicate from the bottom half to the top half. So that is much better, and I think I'm gonna end up going with that. So Yeah, that being said though, getting these chips to communicate with the Raspberry Pi was way harder than I was expecting. Um, like, the demo that I showed wasn't very impressive. It was just flipping through numbers, but like, you have no idea the complexity that went into, like, getting the, like, Raspberry Pi to count up and then communicate that to this, which then communicates that to this. And it was a whole mess, but I did finally get it to work, as you saw. So that's really nice. But you know, the moral of the story is like I squared C is kind of complicated. So yeah, yeah, I actually was planning on showing the code after this, but the code actually isn't that interesting. It's basically just like what I explained just now is like getting the two to communicate and then setting the pins and stuff. But actually, I think I did a pretty good job of explaining that in this part. So I'll leave that for later. But anyway, that's kind of all I wanted to show you this time. So what's next for the future? I guess after this, I kind of have the proof of concept ready. I mean, I have the Raspberry Pi, I have it communicating with the tube. My original plan was to have all 6 of the tubes hooked up at the same time, just to like really have a complete circuit of what it's going to look like before I put it on a PCB. But I have nowhere near enough wires or enough breadboards to be able to do that. Not to mention the shorting out problem I was having before. I just don't think that's very safe. So instead, I think this like proof of concept is good enough. So after this, I'm going to start making a layout in some kind of CAD software. And once the layout is done, I can turn that into a PCB. I can send that PCB design file off to somebody who's going to manufacture it, mail it to me. Then after it gets mailed to me, I have to take all of these components and solder it all on. And then after that, I have to write a new program for the Raspberry Pi to be able to work with the new board. And so needless to say, it might be a while until the next part. That being said, you're absolutely not going to want to miss the next part, because the next part is where it's all going to come together. It's where it's actually going to look like a clock, like what I've been describing. So I think that'll be super exciting. That being said, though, in the meantime, I may just I may do smaller parts, like you know, like I said, I couldn't get these to work, but if I do get these to work in the meantime, I'll show that off. If I can get some cool retro buttons, maybe I'll start interfacing those. Or maybe I'll start using the Raspberry Pi to connect to the internet, like have the one tube that I'm testing show the actual time, and do the weather stuff. I don't know. So there's stuff I could do in the meantime, but the next major part will be the most interesting one, where I actually get the PCBs. So anyway, like I said, you're not going to want to miss this project when it's totally finished. It's going to look super cool. So make sure you're subscribed. I'd really appreciate it. And I will see you in the next video. Bye.